What's up? It's Richesky here with another video. In today's video, we're going to take a look at lesson 4. We're going to be building radical functions. So we'll try to create a radical function that models a relationship between two quantities with and without a calculator. So the warm-up here is some error analysis. It says explain why the graph shown at the near right is not the graph of y equals the square root of x minus 1 plus 2. So before we get into it, let's kind of review from our last lesson. We had sort of this transformation form where it was y equals a times the nth root of x minus h plus k. And recall, this will have a center or starting point at h comma k. So if we take a look at the function, this should have a starting point of 1, 2. And we're going to... All right, so sorry, I had to pause the video there for a moment, but back to our problem. It looks like the error for number 1 is the center point, or rather, in this case, the starting point was in the wrong position. It should be at 1 comma 2, and they put the starting point at 2 comma 1. So we'll just say wrong starting point. Okay, number 2, explain why the graph shown at the far right is not the graph of y equals the cube root of x plus 2 minus 3. So again, here, this is a common mistake people make, is they think the h value is 2. It is negative 2. So this should have a starting or a center point, since it's a cube root of negative 2, negative 3. So again, same sort of issue here. The center point is wrong. So wrong center point. Alrighty, let's move on to example 1. It says write a radical function with the transformation described below from the parent function f of x equals the square root of x. So shifted down 8 units and 5 units to the right. So that function would look like this. F of x equals the square root. So it's 5 units to the right, so that would be x minus 5. And 8 units down, minus 8. All right, so next it is shifted 4 units up. So now the k value would be 4, so plus 4, and 6 units to the left, so that would be x plus 6. Since 6 units to the left, the h value would have to be negative 6. And again, because the form has this minus sign, when h is negative, it actually turns into plus. C, shifted 9 units right and reflects over the x-axis. So this would be, let's say, h of x equals x, x minus 9 square root, and then reflected over the x-axis, so there will be an a value of negative 1. So I'll just put a negative sign in front of that. Shrink by a factor of 1/2. So we'll say, I don't know, I'm running out of, we'll say p of x equals 1/2 the square root of x. Write an example of a cubed root function that stretched and shifts left. So let's do, I don't know, y equals the cube root. So it's shifted left, so we'll say x minus, I don't know, no, left, so it would have to be plus, x plus 2, and it's stretched, so that means there will be a value that is greater than 1. It doesn't say it's reflected, so we'll just go with 2. So 2 times the cube root of x plus 2. All right. In what other form can we rewrite the expression 4x plus 12? Well, we could rewrite this as 4 times x plus 3. Why is that helpful for us? Well, we can then take this after we've factored out a greatest common factor, and we can apply the fact that we can basically take products under radicals separately. So why does that help us? Because we can rewrite this as the square root of 4 times x plus 3, and then I can rewrite this as the square root of 4 times the square root of x plus 3. Square root of 4 is 2. X plus 3 stays there. So this tells us now that we have a stretch of a factor of 2, and we are shifted 3 units to the left. So we'll be working on that here. So look for those GCFs. Here we'll have f of x. I'm first going to factor out the GCF, which is 9. So I would have 9 times x minus 2, which is equal to 3 times x minus 2. So there will be a stretch factor of 3 and 2 units right. Next one, g of x equals, again, I have a greatest common factor, so it's going to be 4 times x plus 5. Then g of x equals, take out the 4, square root it on the way out, so it'll be negative 2. X plus 5 is now the new radicand, plus 8. So we will be reflected over the x-axis. We will have a stretch of factor of 2, and I'm going to try to fit this in. It's going to go left 5, up 8. Okay, now it says write a square root function that has a domain of 5 to infinity and a range of 0 to infinity. So that would mean that maybe this function looks something like that. Well, so that would mean the starting point is 5 units to the right, so that means the radicand would be something like x minus 5, and that's it. It would not be shifted up or down, so we'll just say y equals x minus 5, or sorry, y equals the square root of x minus 5. Write a square root function that has a domain of 2 to positive infinity and a range of negative 3 to positive infinity. So let's see. It would look something like this. That's not a very good graph, but there we go. So shifted 2 to the right, 3 down, starting point at 2, negative 3. So let's call this f of x equals the square root of x minus 2 and then minus 3 outside the radical. All right, we're moving right along here. Write a square root function for each graph below. Assume a is 1. So here, starting point is at 1, 2. So it's going to be x minus 1 inside the radical plus 2. Outside, we're going to assume a is 1, and we'll call that y equals that. Next one, center point is at -2, -3, so that'll be x plus 2 minus 3. We'll call it f of x. Let's see, how are we doing here? I'm going to let you try this one on your own. We'll move down to example 8. Write a cube root function for the graph below. Assume a equals 1. So cube root function looks like my center point is at -2, 0. So no shift left and right, but there is a shift down. So it would look like this. And I will leave example 9 for you to do as well as the closer, and I will see you in the next video.